The box plot will help us to identify the location of the outliers. Since you may be new to box plots, also known as box and whisker diagrams, let us start with the basics. The box plot is made up of two components, a box and two whiskers. This is the box, and these are the whiskers. The box shows the median, the upper quartile, the lower quartile, and the limits within which the middle 50% of scores lie, also known as the interquartile range. The whiskers show the range of scores, the top 25% of the scores, and the bottom 25% of scores. In SPSS, the box plot is also an excellent way for us to see outliers. We are going to create the box plot in SPSS using the dataset clickers.sav. Go to Graphs, Chart Builder, click Reset, and now let's start with box plot. Drag the simple box plot into the canvas. Under Variables, drag the participation for round 1 into the y-axis drop zone and gender into the x-axis drop zone. Click OK. As we look at the resulting output, notice the asterisks with 133 and 157 near them. Those are the outliers. And what do you think those numbers mean? Those are the case numbers of the outliers so that we can find them easier. Now we could scroll through the dataset to find them, and in a smaller dataset that might be practical, but let me show you a trick for when you have a large dataset or a lot of cases to look for. In SPSS, go to Edit, Go to Case. Type 133 as the case number, and then click Go. You'll notice that 133 has risen to the top of the dataset. And as we look at round 1, we see that there is a score of 55. At this point, we need to decide what to do with this outlier. If it is a legitimate outlier, you may choose to leave it in. As we say, outliers are people too. So, if you really have one person who is 6 feet 6 inches tall, that is a legitimate height, and we just happen to have a really tall person in our dataset. However, if this outlier also skews the data because it exerts too much leverage on the mean, then you may switch to a non-parametric alternative test for your later analysis. In other cases, you may have legitimate outliers, but they are non-representative. Say that we are examining the incomes for a professional sports team where most of the players make $75,000 to $100,000, but you have 2 superstar players who make $3 million. You may choose to Winsorize the data. To Winsorize is to trim the outliers to match the highest or the lowest representative value. So if the third highest player makes $135,000, then the 2 superstars' salaries are Winsorized or trimmed to $135,000 for analysis. Now sometimes, as is in the case here, you have data entry errors. We know that the range of possible values was 1 to 7. So 55 is not a legitimate value. It was probably supposed to be a 5 and was miskeyed. Now we can't tell for sure, but that is a fair guess. So we're going to change the 55 to a 5. As a last resort, you can remove the outlier from your data set. Now this is more commonly done when the outlier is a multivariate outlier. In other words, the case has extreme values on several variables, not just one. Regardless of the technique that you decide upon, you should always include details about data cleaning in your write-up and be honest and transparent about how you cleaned the data. So we think that this 55 was supposed to have been a 5. We're going to correct that. And we have one other case to examine. That is case number 157. Go. It has a value of 66. Again, probably a data entry error. We'll change that to 6. Close the go-to box. And now we have cleaned our data set. Running the box plot again is easy. Go to Graphs, Chart Builder. The setup is exactly the same as it was previously, so just click OK. You do not need to make any changes in the dialog boxes because your original box plot settings were saved. This box plot looks much better. We still have some extreme values, but they are within the range of 1 to 7, so they look like legitimate outliers, and we're going to leave them in the data set. While we are at it, let's rerun the bar chart for repeated measures that got us started looking for these outliers. Here we can see what it looked like originally. The mean for round 1 was about 4.5, and the error bar was broader than the other 2 rounds. Well, how does it look now that we have removed the outlier? Let's go to Graphs, Chart Builder. In the gallery, choose Bar and drag Simple Bar up into the canvas. Under the variables, choose Round 1, hold down the Shift key, click on Round 3, still holding down the Shift key, drag all 3 into the Y-axis. Dismiss the Create Summary Group box with OK. And here in the element properties, let's get Display Error Bars. Click Apply and OK. Yes, that looks much better. The mean for round 1 is now closer to 4, and the error bars are similar. Removing the outliers made our bar charts much more accurate and honest.